Alright, good people, I am back with part 2 of physics of the atom, and here we have to look at structure, S-T-R-U-C-T-U-R-E, of the atom, right? Of the atom. So, the atom is made up of subatomic particles. And there are 3 subatomic particles. We have the proton, the neutron, and the electron. Now, the proton, the neutron, and the electron. Each of them has a location, as in where you would find them in the atom. Each of them has a particular mass, and each of them has a particular charge. The proton is found in the nucleus of the atom. So is the neutron. The electron orbits the nucleus. The mass of the proton is, well, really small, 1 AMU, atomic mass unit. The mass of the neutron is also 1 AMU. The mass of the electron is 1 upon 1840 of an AMU. The charge on a proton is +1, on a neutron 0, and on an electron it is -1. Now, I should elaborate on the AMU. 1 AMU is equal to 1.67 by 10 to the -27 kilograms. Yes, that's why they just decided to call it an AMU instead of having to rewrite that all of the time. And also they found that the masses were fairly consistent in that these two had the same mass, and this when the electron had a fraction of the mass of the other two. Now, the next thing we have to look at, isotopes. By definition, isotopes are different forms of the same element. They have similar, I should write the word out, numbers of protons, but different numbers of neutrons. And this is how we define an isotope. The most common isotope that comes to mind is carbon-12 and carbon-14. Carbon-12, if memory serves, I should switch this color. C. Now, I'm going to throw something in here. This is the symbol for carbon. That is 12, and this is 6. This is the symbol for carbon. This is 14, and this is 6. Now, this notation has to be explained, and I will do so now. Sorry for the dog barking, but this is the symbol of the element. This is the mass of the nucleus, or of the atom, essentially. And this is usually the number of protons. So, if we're looking at this atom, well, this one, carbon-12, we have a mass of 12 and 6 protons now. Again, something has to be explained. There is this little formula, A is equal to Z plus N. This is the mass. This is the number of protons. And this is the number of neutrons. If we apply this formula to our carbon 12, 12 is equal to 6 plus n. Our little maths tells us that 6 is the value of n. If we apply the same formula over here, 14 is equal to 6 plus n. Maths should tell us that 8 is equal to n. The number of neutrons is different, even though, or in spite of, the fact that the number of protons for each is still 6. These two are isotopes. Have I forgotten anything? One second, let me consult the syllabus. Yes. Now, the syllabus requires you to understand why atoms are neutral. I'm sure if you did some chemistry, you'd realize that an atom that is not electrically neutral is what we call an ion. Atoms are stable and neutral because of the simple fact that if they weren't, most of what we see around us would not exist. Things would be in a constant state of flux or decay, or attempts to move to a state of balance. So I hope that clarifies the question of why atoms are balanced. Well, they said stable, I said balanced. Are stable and neutral, and that is because they have to be. If they weren't, we would be in trouble. Now, what does this mean? Going back to this formula, we don't really need to worry with our neutrons because they don't have any charge. If these two have 6 protons apiece, it means they also have 6 electrons as well, because that is the only way they'd be balanced. You would have a charge of +6 for your protons, -6 for electrons, and when you combine the two, your total charge is 0. And that's it for this video.